And we call it the gamma function is this, and then gamma of k plus 1 is the integral from 0 to infinity with the integrand t to the k times e to the minus t. And then also gamma of k plus 1 is equal to k times gamma of k. And so here we have the random variable x with the gamma distribution that has a gamma distribution, and this is the gamma probability density function. In an earlier video, we have found that the expected value of x, or the mean of x, is k times theta. And for this video, see the description for the video link. And now we want to find the variance of x. The variance of x is the expected value of x squared minus the expected value of x squared. And we want to show that the variance of x is k times theta squared. So we have already found the expected value of x, which is k times theta. And so to find the variance, we just need to find the expected value of x squared. So the expected value of x squared will be the integral from 0 to infinity with the integrand x squared times f of x. And so f of x is just the gamma PDF. This integral is with respect to x. In this expression here, there's no x, so it is considered a multiplication constant, so we can move it and place it in front of the integral. What's left is x squared times x to the k minus 1 times e to the negative x divided by theta. X to the second times x to the k minus 1, we just add 2 and k minus 1. So 2 plus k minus 1 is k plus 1. Now let t be x over theta, x over theta. Then dt dx will be 1 over theta, dt will be 1 over theta times dx, and multiply both sides by theta, we have theta dt is equal to dx. T is equal to 1 over theta times x, and so x is equal to theta times t. We need x to the k plus 1, so from here, raise both sides to the power of k plus 1. So we have x to the k plus 1 equal to theta t to the k plus 1, which is theta to the k plus 1 times t to the k plus 1. From here, in the place of x to the k plus 1, we have theta to the k plus 1 times t to the k plus 1. X over theta, that's t, so we have e to the negative t. Dx is theta dt. theta to the k plus 1 times theta to the first will be theta to the k plus 2. And then this is just a multiplication constant with respect to t. So we can move it and place it in front of the integral. And so this integral right here, this is the gamma function, gamma of k. So gamma of k plus 1, we just put k plus 1 in the place of k. And so we end up with t to the k, e to the minus t. K plus 2, then in the place of this k right here, we put k plus 2. K plus 2 minus 1 is k plus 1. So the integral from 0 to infinity with the integrand k plus 1 times e to the minus t is gamma of k plus 2. Gamma of k plus 1 is k times gamma of k. So we have gamma of k plus 2 and then we can write this as gamma of k plus 1 plus 1. So gamma of k plus 2 is gamma of k plus 1 plus 1. Gamma of k plus 1 is k times gamma of k, so gamma of k plus 1 plus 1 would be k plus 1 times gamma of k plus 1. But gamma of k plus 1 is k times gamma of k. And so gamma of k plus 2 is k plus 1 times gamma of k. And so that's what we have right here. Gamma of k plus 2 is k times k plus 1 times gamma. Gamma of k dividing by gamma of k is 1. So what's left is theta squared times k plus 1. And so this is the expected value of x squared, where x is the random variable with the gamma that has a gamma distribution. And so in summary, the expected value of x in an earlier video is theta times k. We just found that the expected value of x squared is theta squared times k plus 1. And therefore the expected value of x, which is the expected value of x squared minus the expected value of x squared. It would be theta squared times k plus 1 minus theta k squared. Multiply this out, and we end up with theta squared times k. So this is the variance of x, where x is a random variable that has a gamma distribution.